While setting up a message system is a great way of learning the basics of multiplayer connections, it doesn't provide you with all the knowledge you'll need to create two players on two separate devices and keep them synced. In this tutorial, you will learn how to connect two separate devices using IP addresses, create two players on each device, and keep them synced using remote procedural calls. $31,400 is the RPC port. I like to remember it by thinking of the first 3 digits of pi. This testing IP is used to connect to yourself through your device. This simply allows you to test your game while you're offline. Each player connected to the server has a unique network ID. This is what we use to identify each player. In local multiplayer, peers connect across the host's private IP address. This function gets the unique network ID of the current game instance and all other game instances connected. This function must be run after all instances are connected, or else it will be unable to get their network IDs. Since the lobby is a user interface, we start with a control node. This IP label will show the player their private IP, so when they host, they can share it with the players joining them. This line edit is where a player looking to join someone will type the host's private IP. This invalid IP label will appear if a player types something that is not an IP address in the line edit. This connecting screen will just tell the player that they are connecting. Now to the scripts. This line sets the IP label's text to the current device's IP address. When the host button is pressed, it will run this function, telling the network we set up earlier to host the server. It will also tell the connecting screen to appear. The set connecting type signal will be connected to the connecting screen to tell it to appear. When the join button is pressed, it will first check to see if the player entered a valid IP address in the IP text edit. If it is not valid, the button will show the invalid IP label. The join function works pretty much the same as the host function, except that it joins the server and displays different text on the connecting screen. The first string in this array will be displayed on the host's connecting screen, and the second will be on the client's. When the client connects to the server, the connected function will be called on their game instance. Since this function is only called on the client side, they also need to tell the host to start the game on their side as well. Now it is time to create the player. The tricky part about this is that this player needs to be controlled by one player as well as update its position on the other player's screen. The isMaster variable will allow the player to be controlled by one game instance and not the other. This initialize function will set the player instance's name to the unique network ID of the device controlling it. RPCs will only execute a function on the node with the same path as the node it is sent from. Therefore, the player controlled by the host must have the same name as the player controlled by the host on the client side, and vice versa. The physics process function contains what you normally expect from a top-down player script, with the addition of an unreliable RPC. An unreliable RPC does not ensure that the data will actually get to the other player, but it does mean that if it does, it will be fast. The update position function is the function called by the unreliable RPC. All it does is set the player's position to the position sent. Since the host and client are connected by the time the game scene is launched, proven by the fact that an RPC to start the game was sent successfully, the setIDs function should be able to get the unique network IDs of both. The createPlayers function creates a player for each network peer connected. The createPlayer function creates an instance of a player and then calls its initialize function and passes in its ID. If you want to test your game offline or simply make sure it works before exporting it, you can launch 2 instances of it by opening the project manager and clicking Run twice. When I tested this game on the day I recorded it, I realized that private IP addresses on Mac will not always be in position 7 in the function getLocalIPs. So if you used Mac, you may have to print all local IPs and find out what position your private IP is in. It should have 4 numbers and shouldn't start with 127. If you enjoyed this tutorial, feel free to like and subscribe. And if you have any questions, leave them in the comments below. I'm GamemakerPixel, and thanks for watching.